Okay, this is the fifth and final video for the circle at National 5, and it's how to find the area of a sector. Now, if you've already watched the fourth video, which was the arc length, the ideas that we're doing here are exactly the same for arc length. Just a different formula, but all the examples will look very similar if you've already watched the last video. Okay, area of a sector. So what's that all about? Well, area of a sector is the area of part of a circle. So if you look at this wee bit here, there we go, this area in here, slice of cake if you like. To work out that area, the connection is to do with the whole circle, just like arc length. So it's all to do with the angle at the centre over the angle of a full circle, and that ratio is the same as the area of a sector, this wee part here, over the area of the full circle. So let's just sort of define that. So angle at the centre for the sector, for the sector, over 360 is exactly the same ratio as the area of a sector, AOS for area of a sector, over the full area of a circle, which you should know from first year, which is pi r squared. And if we just rearrange that again using changing the subject topic that you've done before, rearrange that into AOS equals, well, we just multiply both sides by pi r squared, and then we swap it around as well. So let's multiply first. So angle at the centre over 360 times pi r squared is equal to AOS. So we just swap everything over to get a final formula. AOS is equal to angle at the centre over 360 times pi r squared, and that's your formula. And just like for the arc length, you have to remember this formula. You don't get it in the exam. Based on you've watched the last video, here's a connection that I like to use quite a lot. The angle at the centre over 360 is equal to the arc length over pi d from the last video, is the same as the area of a sector over pi r squared, and that's how I remember it. I just rearrange whatever I need from there. Okay, so that's quite a handy way of remembering these formulas. Okay, and depending on what you're doing, if you're doing arc length, then you won't need the area of a sector if you've got the angle, that is. And the same idea, if you're finding the area of the sector, you won't need arc length, and you need these two. Have saw come up before that you don't have the angle, you're not given the angle, and you're given the arc length and some other wee bits that you have to use these two, but that's very rare. Let's go back to area of a sector and just work out the simple stuff first. Over on the right hand side, here's a past paper question. Can't remember what year it is, but it's come up, wasn't worth an awful lot of marks, maybe 2 or 3 marks, and we have to find the area of this sector. So we have to find the area inside, so it's the area inside here we have to work out. So again, just remember, arc length is round the outside, the curvy bit. Area of the sector is the bit inside. So area of sector. Write down the formula. Area of a sector is equal to the angle at the centre over 360 times pi r squared. Okay. Area of the sector is a fraction of the whole circle. That's a good way to think about it. Okay, that angle is 72 over 360 times pi 5 squared. And all you have to do is bump that into your calculator and write down the formula. Now, it's quite important in these type of questions that you actually make sure you put in the units. Don't forget the units. It's quite often that at National 5 level there's somewhere in the paper you get deducted a mark if you don't put in the units, and quite a lot of times it can be this question that they pick to do that. So we've got 72 over 360 times pi times 5 squared. And that comes to 5 pi, which is approximately 15.7. 15.7. And it will be centimetres squared because it's area. Okay, so that's a nice easy question. Let's see if we can come up with something maybe a wee bit harder than that. So area of the sector, let's try and find one that we have to find the angle. So just rub this one out and I'll just make up a question and we can find the angle at the centre. So let's draw our arc. So, make it at the top this time. The centre's round about here. Join them together. And just work up some values. Yeah. To here. I'll just put X degrees for the angle. Let's make the radius 4 centimetres, and we have to work out, and well, we'll have to have an area. So I think I'll just come up with an area for that. Let's make the area 8.4, say. So the area of the sector is equal to 8.4 centimetres squared. So in this question we're given the area, we're given the radius, and we're asked to find out the angle in here. Okay, so we're given this area in here. That's your 8.4 centimetres squared. So first thing, write down the formula. So angle at the centre over 360 is equal to the area of the sector over pi r squared. Now, I wrote it in this format, okay, that was it over here. Wrote it in this format because it's going to be easier for me, because I'm finding the angle, and we know this, and we're given that in the question, and we're given the radius, that's in the question, so we'll just find the next here. So remembering in this format, all I have to do is multiply both sides by 360. So x is equal to, and that's x degrees, is equal to area of the sector over pi r squared times 360. Plug in the numbers, so that's 8.4 over pi 4 squared times 360. And again, we just plug that into our calculator and come up with an answer. So let me just do that. So 8.4 divided by pi, and then divided by 4 squared. Well, 4 squared is 16, so we're going to divide by 16, and then we're going to times by 360. And approximately 60.2. Okay, 60.2 approximately degrees. Okay, and that's a working backwards question. So again, that's deemed like an AB type question. It's not a C level question, because a good bit of thinking in that, and you've got to try and work backwards to find the angle. Okay, well, I'll do one more example, and this example is going to find the radius this time. So let me just draw another arc. So let me just do it to the left this time. So the centre's round about there, so let's put it in there somewhere. Join them up. Up here. Okay, so circle. Let's call that, I don't know, 50 degrees. And the area of a sector, we'll just put over here, area of a sector equals, I don't know, we'll make it 70.4 or something centimetres squared. So this time we have to work out the radius r. Okay. So what's the best way to do it here? Well, there's not really any better way. Just let's start from the ratio. Angle at the centre over 360 is equal to area of the sector over pi r squared. So this time we're trying to find the radius, so quite a wee bit of manipulation here. So what I'm going to do first is I'm going to multiply through by 360. So that's going to give me x degrees then is equal to area of the sector over pi r squared times 360. I'm then going to multiply through by r squared. So multiplying through by r squared, that's x degrees r squared is equal to area of the sector times 360 over pi. I didn't move pi, I've only multiplied through by r squared. And the last wee bit, we want to get rid of the x there, so we're going to divide through by x. So that's got area of the sector over pi x degrees times 360. And then once we've found that, we take the square root. So let's just work it all through without any numbers so far. So area of the sector over pi x times 360. So there's me using my knowledge from changing the subject. I've changed all that round without putting any values in. And as I said in the last video, it's very good practice for you to do that. It helps you with the changing the subject question that comes up at National 5, and that question comes up all the time. So always good to do that. So last wee bit, let's put our values in. So we've got the square root of 70.4 over pi times 50 times 360 and take the square root of all that. Okay, and that'll give me my radius. So just take your calculator. So we've got 70.4 divided by pi and then divided by 50 and then times all that by 360. And then we take the square root of that, take the square root of that answer, we get 12.7. So the radius of that sector is equal to 12.7 centimetres. Okay. Definitely the hardest question I think you could get, because of quite a bit of manipulation in that. But practice them, they come up fairly regular. If you're lucky you get a nice easy one in the exam, but at some point they've got to put a more difficult question in, and they might choose the circle to do that. Okay, so that's everything we've learned at National 5 for the circle. There's 5 videos in this. Okay, if you're looking for past papers, I've got 20 years of past papers at nationalvision.com. Just click on the National 5 section and go down to the bottom, you'll see a big star. Click on that and you'll see 20 odd years past papers at National 5 with all credit as well in there. And if you can do all them, then you end up getting an A in the exam if you can do all those past papers and get a good mark from them. Okay, that's it.